Hello everyone. In today's lecture, we're going to see the fundamentals of IP addressing. IP address are unique and universal. The size of IP address is 32-bit long. The address space IPv4 occupies is, since the size is 32-bit, the total space will be 2 power 32. This IP address, you can represent them in two notation. One is the binary notation, the other one is the dotted decimal notation. So you can see here, this is the binary notation and your decimal notation or dotted decimal notation will look like this. IPv, there are IP, there are two versions. One is IPv version 4 and the other one is version 6. The main difference between IP version 4 and IP version 6 is that the size of IP version 4 is 32-bit. The size of version 6 is 128-bit. It's address size. Coming to IPv4, it is a 32-bit address that uniquely identifies a node in the network. For example, if you want to identify a system in the network or in the internet, you can identify this node by means of an IP address. So two devices on the internet can, can never have the same address at the same time. Addressing system must be accepted by any host that wants to be connected to the internet. As I told you that IP address you can represent them into two notation. One is the binary notation, the other one is the decimal notation. We'll see how this addresses is segregated. So one half indicates the network part and the other part indicates the host part. When I'm representing the IP address in decimal notation, the range is it is between 0 to 255. IP address, you can classify them into two parts. One is the classful addressing, the other one is the classless addressing. In today's lecture, we are going to see only about the fundamentals of classful addressing. So in classful addressing, the IP addresses, they are divided into 5 classes: class A, class B, class C, class D, and class C. So we'll see what is the difference between all these types of addresses. So when you take this class A address, I told you that any address is divided into two parts. One is the network part, the other one is the host part. So in a class A address, the first octet indicates the network ID. The next three octets indicate the host ID. In class B, the first two octets indicates the net ID and the next two octets indicates the host ID. In class C address, the first three octet indicates the net ID and the last one octet indicates the host ID. But in class D and class E, there are no segregations because class D is mainly assigned for multicasting and in class E, it is reserved for future use. How do you differentiate address is a class A address, class B address, and class C address, and so on? So we can differentiate between these addresses by seeing the starting value in the network ID of each class. So in class A, in the network ID, the first value will be 0. For class B, it starts with 10. And for class C, it starts with 110. And in class D, it starts with 1110. And for class C, it starts with 111. So looking at these starting values, you can differentiate whether it is class A, class B, for class C, class D, and class C. So we'll see the address space occupied by these classes. So you can see that as I told you, for class A it starts with 0, class B it is 10, class C it is 1110, and class D it is class C it is 110, class D it is 1110, class C it is 4 ones followed by all ones. We'll see the space it is occupying. Class A occupies 50%, the value will be 2 power 31. Class B, it occupies 25%. 2 power, the value is 2 power 30. For class C, it is 12.5%. For class D, it is 6.25%. And class E occupies 6.25%. So this diagram depicts the occupation of address space by different classes. So coming to this table tells you the class range for each classes. So we can see that this was discussed already, the starting range for class A, class B, class C, how it starts, class D on. Coming to this segregation of network ID and host ID, in class A, the network ID is 8-bit, class B it is 16-bit, class C it is 24-bit, and class D and class C it is not defined. Coming to host bit, the number of host bit will be 24-bit for class A, for class B it is 16-bit, for class C it is 8-bit. So the number of networks in each classes will be 2 power 7 for class A, 2 power 14 for class B, 2 power 21 for class C, and for class D and class C it is not defined. Number of uh, hosts in each network will be 2 power 24 for class A, 2 power 16 for class B, 2 power 8 for class C, and for class D and class C it is not defined. Now one thing you should understand that in class A the number of hosts is many, the number of networks is less. When class B it is moderate, number of networks is 2 power 14, number of hosts is 2 power 16. And in class C, you can see that the number of networks are more and the number of hosts in each network is only 256. And usually we take this class C for supernetting. We'll discuss that in later, what is meant by supernetting. And in decimal notation, we'll see what is the starting range for class A and class B, class C, and so on. So in class A, it starts with 0.0.0.0 and ends with 127.255.255.255. So usually this 0.0.0.0 address is not used. So when you take any network ranges, always the first address is assigned for the network and the last address will be used as a broadcast address. So for a class B, the starting range will be 128.0.0.0 and ends with 191.255.255.255. And in class C, it is 192.0.0.0 and ends with 223.255.255.255. And in class D, it is 224.0.0.0 ends with 239.255.255.255. And in class E, it is 240.0.0.0 and ends with 255.255.255.255. Coming to the number of classes and number of blocks in each class, we see that in class A you have 128 blocks, class B it is 16384, and class C this is the number of blocks. That is 2097 152 is the number of blocks, and class D it is only one block and class C it is only one block. And the block size for the host address or host part will be these values. And for what application it is used, class A is used for unicast, class B again used for unicast, class C is again used for unicast, whereas class D is used for multicast and class C is not at all used and it is reserved for future use. In classful addressing, one disadvantage is a large part of the available addresses are wasted. Coming to the default mask for classful addressing, see this mask value will be useful when we do subnetting. So the subnetting will be discussed later when you do subnetting. So for a class A address, the mask value, it is a standard mask values. It is 255.0.0.0 and it is represented as /8. The address followed by /8. In class B, it is 255, mask value is 255.255 dot 0 dot 0, and in CIDR notation it represents as /16. The CIDR is classless inter-domain routing it is. And for class C, the range is mask value is 255.255.255.0. In CIDR notation, it is /24. Usually an IP address is represented in this format. IP address followed by /n, where n indicates the mask value. So when you compare this classful and classless addressing, classful addressing, because the number of addresses are wasted, we always prefer classless addressing. That will be discussed in the next topic. Thank you.